This is a graph of the heating curve for water. As you can see, the y-axis is temperature and the x-axis is time or energy. So over time, we are adding energy and the temperature is generally increasing. We are starting with ice. So at our initial times, we just have solid ice. Once we hit 0 degrees Celsius, our ice melts into liquid. So here we have a mixture of solid and liquid, and that is during our melting time. Once all of our ice has melted, we only have liquid. And then once we reach 100 degrees Celsius, which is the boiling point for water, the water starts to boil. So now we have a mixture of liquid and gas in our solution until all of our water has boiled off and we're left with only gas. So the question is, what is really happening at each of these pieces of our heating curve? We're going to start down at the bottom with solid. So at solid, our temperature is increasing. That means the movement of molecules is increasing. So this is an image of solid water molecules. There are very strong attractions between solid water molecules, and that holds them in this crystal structure. So they are stuck together in a crystal structure. We are increasing the energy. We are increasing over the period of time, and they start vibrating. They are moving a little bit. They are still stuck together in this crystal structure, but each individual molecule is vibrating a little bit. Then it starts to melt. Once it starts to melt, we have enough energy to actually break these bonds. So these bonds are now breaking. The molecules are not moving any faster. The temperature of our water is not increasing, so the molecules are not moving any faster, but these bonds are breaking. And liquids, in a liquid, the molecules will rearrange themselves and new attractions will form. These attractions are a little bit weaker, but they still hold those water molecules together, but now they're in the liquid form. So once all of our solid attractions have broken, we have totally melted our ice. We have finished melting and we only have liquid. So notice once we only have liquid, our temperature of our liquid will increase over time, which means as we add heat, as we add energy, these liquid molecules start moving faster and faster and faster until we have added enough heat that they are moving fast enough, and they are moving fast enough that we are at 100 degrees Celsius for water, and we are at boiling. The molecules start boiling. So again, the temperature of boiling at our boiling point does not change. It remains constant, which indicates that our molecules are not moving any faster. Instead, that energy that we input is breaking these bonds that have formed between our liquid molecules and allowing our water molecules to separate even further and become gas molecules. Once all of our water has boiled, all that liquid has boiled, all of those attractions are broken, we now have gas. So notice again, with gas, the temperature increases, which means that our molecules start moving even faster. They are moving faster and faster and faster. And every time molecules move faster, we see an increase in temperature because heat is a measure of the speed at which molecules move. So as they move faster and faster and faster during this gas phase, temperature is increasing.